All right, I'm sure the part that you've all been waiting for, where can I actually use this, or where is it used? So we have some word problems for you. The loudness of a sound is measured in decibels and can be calculated using the formula shown, where L is the perceived loudness of the sound, is the intensity of the sound being measured, and I subscript O is the intensity of the sound at the threshold of human hearing. So we're told that's 10 to the power of negative 12. So our first question is, the sound intensity of a person speaking in a conversation is 10 to the power of negative 6. What is the perceived loudness? Okay, so we're going to use this formula right here. Loudness is equal to 10 log I over IO, where IO is our intensity of the threshold where we can actually start hearing. So I'm going to put this as A, and we have our loudness is equal to 10 log. Now we're looking for the loudness. We've been given the intensity of the sound. We're told that it's at 10 to the power of negative 6. Now our threshold is 10 to the power of negative 12. So we're going to simplify inside of this logarithm first. So it becomes negative 6 minus negative 12, which becomes 10 to the power of 6. Now what's really important here is we actually have a base 10 here. So the bases are the same of the log, and the base of this power is the same. So that means it's going to equal 6, this logarithm. So then our log is equal to 10 times 6. Or our loudness is 60 decibels. Okay, part B says we're going to a rock concert, has a loudness of 110. Oh, what is the sound intensity? So we're going to start in the same place with our formula. We're told that the loudness is 110. And we still have 10 log. Now we're looking for I, or that perceived intensity. So that's going to stay like that. And we already know what our threshold is, which is 10 to the power of negative 12. So this question is a little bit different in that we have to actually isolate something inside the logarithm. The first thing I would do, I've got to 10 times this log. I'm going to divide both sides by 10. So I get 11 is equal to log I over 10 to the power of negative 12. Next, I'm going to split this log apart. So I get 11 equals log I minus log 10 to the power of negative 12. It's really important again that this log is actually a base 12. Again, the bases match. So this logarithm is equal to negative 12, but it's actually going to become positive 12 here because we've got a minus in front of it. So log I minus negative 12. So I'm going to subtract 12 from both sides. So I get 1 is equal to log I. I'll write that 10 in there again just to make it a little bit more clear what's going to happen. We need to write this in exponential form now. So I've got 10 to the power of, this should be a negative 1, equals I. And there is our answer to our question. Our intensity of sound is going to be 10 to the power of negative 1. So I made a little room for C. So two sounds have decibel measurements of 85 decibels and 105 decibels. Calculate the intensity ratio of the two sounds. Now to do that, I'm actually going to subtract these 2 decibels on the one side, so 105 minus our 85 decibels, to see what the ratio actually is between these. So here if I have loudness 1 minus loudness 2, or it could be the other way as well, on the other side of the equation, I'm going to put loudness 1 minus loudness 2, but the right side of this equation. So that's going to be our 10 log I1 over I0 minus 10 log I2 over I0. Now we want to simplify as much as we can. So I can divide everything by 10, or each term by 10, and I also do the subtraction as well. So I'm going to get 2 equals log I1 over I0 minus log I2 over I0. Now these are both logs, same base, So then I can use my quotient law. So it's going to be log and then brackets. Now I'm going to do this. I don't want to do a complex fraction. So I'll actually write this as a division. I2 divided by IO. And I'll reciprocate the second fraction and turn it into multiplication. So we got 2 log. So the first fraction stays the same, turns to multiplication. I'll make that into a dot so we don't get confused. And then reciprocate the second fraction. Now what's nice about this, because this IO is a constant in our case, they're the exact same, we can cancel those out. So we're left with 2 equals log and then I1 over I2. Then we can turn this into an exponential graph. So we've got a base of 2. So we get 10 squared is equal to I1 over I2. So now we have the ratio, the intensity ratio that we're looking for the two sounds. I know it's a ratio because these are being divided right now. I could simplify this to 100. You can see sometimes, often we'll leave that in this power format though as well. Depends what the question is asking for. All right, our last part of the question says that part C required multiple steps because we were comparing each sound with IO. Instead of comparing the two sounds to each other, it is possible to derive the formula. So we have this formula here, which compares two sounds directly without requiring IO. Derive this formula. We actually did a lot of the work already to make the formula. So rather than redo all of this work again, I'm actually going to just change a couple little steps. So here you can see in red I have L1 minus L2. In the formula they have L2 and L1. It doesn't really matter too much. So I'm just going to erase this, and actually I'm just going to keep our L1 minus L2. Now that means in my second step, this is also going to be the same thing. So pretty much the whole way along that's going to change. It's not going to seem like we're saving much work yet, but the right side actually stays a lot more similar. Now when we went from this step to this step, we actually divided everything by 10. So we don't know what L1 minus L2 divided by 10 is, so we'll leave that like that. And already you can see we have this part right here. And I'll just rewrite that one more time. Now on the left side, right side, everything stays the same so far. We have no other numbers that we've changed. We still want to use the logarithm law to combine these logs, divide them, cancel out the IOs. That's all the same. So far, good. Looks like we're saving lots of time. Just got to keep on writing this L1, L2 over 10, and then L1, L2 over 10. And actually, this step is the same as well. The only difference is, instead of this being 10 squared, it's going to come out to be, we have 10 to the power of. So that squared is this right here. This is our new exponent, because it's 10 to the power of this. So we get 10 to the power of L1 minus L2 over 10. Now, I know that the 1 and the 2's are switched, but if I switch these two would also change places as well.